Hello, and welcome to this lesson on methods for preventing the rusting of iron. In today's lesson, we will explain different methods for preventing the rusting of iron through 3 techniques. We'll start by understanding how using protective coatings such as paint, varnish, or oil prevents rusting by isolating iron from oxygen and moisture. We'll then learn how to prevent rust formation on iron surfaces by minimizing moisture exposure and applying waterproof coatings or desiccants. Finally, we will understand how sacrificial protection uses more reactive metals, like zinc or magnesium, to prevent iron corrosion through galvanization. By studying various rust prevention techniques like the exclusion of oxygen, the exclusion of water, and sacrificial protection, we can extend the lifespan of iron objects and structures. Rusting occurs when iron reacts with oxygen in the presence of moisture to form iron oxide, or rust. One effective method of preventing rusting is to prevent iron from being exposed to oxygen. To achieve this, we can apply a protective coating on the iron surface. For instance, paint, varnish, or oil can act as barriers that prevent oxygen from coming into contact with the iron. When iron objects are painted or varnished, a thin film is created over the surface, effectively isolating the iron from the surrounding air. Similarly, oil can be used to coat iron surfaces, providing a protective layer that prevents oxygen from reaching the metal. Another essential factor in the rusting process is the presence of moisture. Keeping iron surfaces dry or minimizing their exposure to water can prevent rust formation. Applying waterproof coatings such as plastic, enamel, or special moisture-resistant paints can keep water away from iron surfaces. Additionally, storing iron objects in dry environments or using desiccants, which absorb moisture from the air, can also significantly reduce the likelihood of rust formation. For instance, silica gel packets often found in packaging serve this purpose by absorbing moisture and keeping the environment around the iron dry. Sacrificial protection involves using a more reactive metal to protect iron from corrosion. This method takes advantage of the fact that certain metals, like zinc or magnesium, are more reactive than iron. When these metals are used in conjunction with iron, they corrode preferentially, sacrificing themselves to protect the iron. One common application of sacrificial protection is galvanization. In this process, iron or steel is coated with a layer of zinc. Zinc, being more reactive, will corrode before the iron, thereby preventing rusting. Even if the zinc layer is scratched, it will continue to protect the iron through a process called galvanic action, where the zinc corrodes in preference to the exposed iron. A similar approach is the use of sacrificial anodes, pieces of more reactive metals, such as zinc or magnesium, that are attached to iron structures, especially those submerged in water, like ships or pipelines. The sacrificial anode corrodes instead of the iron, effectively protecting the structural integrity of the iron object. By applying these methods, we can significantly extend the lifespan of iron objects and structures. This not only saves money on repairs and replacements, but also has important applications in various industries and everyday life. In today's lesson, we delved into the methods for preventing the rusting of iron, focusing on 3 key techniques. We learnt that rusting occurs when iron reacts with oxygen in the presence of moisture, forming iron oxide. Applying protective coatings like paint, varnish, or oil can effectively prevent rusting by isolating the iron from oxygen. We also saw that minimizing exposure to moisture is key to preventing rust on iron surfaces. Applying waterproof coatings and storing iron in dry environments or using desiccants like silica gel can significantly reduce the likelihood of rust formation. Lastly, sacrificial protection uses more reactive metals like zinc or magnesium to prevent iron from corroding by allowing these metals to corrode first. This method, commonly seen in galvanization and the use of sacrificial anodes, ensures that iron structures remain protected even if the protective metal layer is damaged. See you next lesson as we look at electroplating.